Hello, very good morning to all. I hope my voice is clear to all. I'm audible? Yeah. Okay. So what we are going to do today our topic is chemical bonding. Okay. So we are going to solve all PYQs related to chemical bonding. The PYQ question asked in last 4 to 5 years, they are the most important PYQs. And by solving such PYQs, we also focused on the concept behind this question. So, what our plan for today class is, by solving PYQ and by remembering some concept, we can able to solve some more and more question related to this topic. So today class is going to be very interesting. So let's start with the today class that what we are going to solve in chemical bonding. Basically, chemical bonding is very easy chapter. If you remember some small tips and tricks, then you can easily solve 2 to 3 questions very easily. So it is going to be very interesting class. Okay, so let's start with the today class, right? I hope everyone join. Yeah. Beta, if you have any doubt related to any question, please ask me in the chat box. I am going to reply each and every queries of you. Okay? Sure. So let's start with the today class. The first question, and this question comes in 2023 SIF 2 24 Jan questions. So what questions state that? What is the number of unpaired electron in the highest occupied MOT, that is molecular orbital, of the following species? So this question, what is the concept behind this question, beta? Yes, I'm going to discuss each and every concept of the PYQ. Okay, so this question is basically from MOT theory. MOT theory. So we know that in MOT theory, how to write electronic configuration. Okay, so in MOT theory, how we can write electronic configuration, beta? From hydrogen H2 to N2. We write electronic configuration like sigma 1s2 sigma star 1s2 sigma 2s2 sigma star 2s2. Sigma 1s2 means bonding orbital and sigma star 1s2 means anti-bonding orbital. So this is sigma 1s2, sigma 1s2, sigma 2s2, sigma star 2s2, and next is pi 2px, okay, pi 2px2, and which is equal to pi 2py. Both they are called degenerated orbital because their energy is almost same, pi 2px and pi 2py. And the next is sigma 2pz. Okay, this is sigma 2pz. So if I'm talking about nitrogen, okay, so nitrogen having electronic configuration what? That is 1s2, 2s2, and 2p3. Okay, so that is 1s2, 2s2, and 2p3. 2 to 4 and 3, 7. Okay, now this is 1s2. So this is 1s2, sigma star 1s2, 2s2, sigma star 2s2, sigma 2s2. Now, if I'm talking about 2p orbital, that is pi 2px2. So it is pi 2px2, pi 2py2, and sigma 2pz. So if I'm talking about the electronic configuration of nitrogen, then just remember one fact, that is N2. It means it having 2p electron, right? So that is in this highest occupied orbital means what? That is highest occupied. Highest occupied means the last one. Their energy is very much. Okay, so if I'm talking about this orbital, so they contain a paired electron, two paired electron. There is no unpaired electron in this. Similar, if I'm talking about N2 plus, right? If I'm talking about N2 plus, just remove one electron, so it will become sigma 2pz1. Okay. Next, if I'm talking about O2, if I'm talking about O2, so in case of O2, it will become just try note one thing from O2 to नियॉन। ओके, इसका ध्यान रखना बेटा कि O2 से नियॉन, ये जो दो चीजें होती है ना, इसके लिए इलेक्ट्रॉनिक कॉन्फ़िगरेशन में थोड़ा सा चेंज होता है। क्या? देखो, in this for O2 to Ne2, the electronic configuration becomes sigma 1 is to sigma star 1 is to sigma 2 is to sigma star 2 is to, and sigma 2pz come first. Okay, instead of pi 2px, sigma 2pz come first, and then pi 2px and pi 2py. Okay, so this is for what? This is for O2, right? So this is for O2. So you can write, and next is pi 2px star and pi 2py star. Okay, so in this one electrons. And we know that MOT theory explain that O2 is a paramagnetic in nature because in their highest occupied orbital they contain one unpaired electron, as you saw now एक एक इलेक्ट्रॉन यहाँ पे है, तो it contain one electron in their highest occupied orbital. Okay, if I'm talking about O2 plus, O2 plus means what? Just removal of one electron, that is pi 2px1. So you have to calculate in this question what is the number of unpaired electron. So if I'm talking about N2, is there any unpaired electron in N2? No, because there is a two electron and both are paired. So there is no unpaired electron. It means in N2, one paired electron is 0. Right? Got it? Now, if I'm talking about N2, in N2 plus, okay, in talking about N2 plus, N2 plus having one unpaired electron, right? So it having one unpaired electron. So N2 plus having one unpaired electron. If I'm talking about O2, O2 having two unpaired electron in the highest occupied orbital, that is pi 2px star 1 and pi 2py star 1. So it having two unpaired electron. Now if I'm talking about O2 plus, it having only one unpaired electron. So which one is the correct option? 0 1 2 1, 0 1 2 1. So the option number 1 is absolutely correct. I hope you understood this question and the concept behind this question. So this question is basically based on the MOT theory and the way you write the electronic configuration. Just remembering one important note here, that for electronic configuration from hydrogen to N2, we use this type of configuration, like sigma 1 is to sigma star 1 is to sigma 2 is to sigma star 2 is to pi 2px2 is equal to pi 2py, then sigma 2pz. But in case of oxygen, fluorine and neon, sigma 2pz come first. After this, pi 2px and pi 2py come. And highest occupied molecular orbital means having highest energy, which is outermost. Okay. So I hope it is clear, and by using such concept, you can able to solve as many questions as you can. Okay, so I hope it's clear. Next, move to the next question, and we discuss about the concept and the level of the question also. So I think this question is a medium question. We can't say it's a very easy question, but it is a medium question. You can solve such type of questions. Okay, good. Now, next move to the next question. What question asks the total number of lone pair of electron on the oxygen atom of ozone. So for such type of question, you need to draw the structure. Without drawing a structure, you are not able to find the lone pair of electron, or we say bond pair of electron. So for such type of question, you need to draw a structure first. So we all know that if I'm talking about ozone structure, right? So how will you draw the structure of ozone, beta? Ozone means what? That is O3. O3 means O, O, and O, right? So there's a many rules to draw the structure. I'll share with you one easy rule. By using such rule, you can easily draw the structure of this ozone. If I'm talking about oxygen, oxygen having how many valence electron? 2 comma 6. It having 6 valence electron. So 3 oxygen having 3 into 6, that is 18 electron. So total it having 18 electrons. Okay. Now let me draw like this. If I make oxygen oxygen single bond and oxygen oxygen double bond, then we all know that in one bond there is a two electron. Okay, so one bond, two bond, three bond. The total number of electron 6. So 18 minus 6, that comes out to be 12. Now make the central atom happy first. What do you mean by this term happy? Happy means it having 8 electrons. Try to complete their octet. Okay. So give 2 electrons because the 2 electrons, 2, 2, 6 and 2, 8. So minus 2. Remaining electron, how many electrons are remaining? 10. Okay. Now central oxygen is completed their octet. Okay. Now we also name the oxygen like oxygen number 1, oxygen number 2, and this is oxygen number 3, right? So this is oxygen number 3. Okay. So if I'm talking about oxygen number 1, it having only one bond, that is 2 electron. So it needs how many electron to complete their octet? 6 more electron. That is 2, 2, 4, and 2, 6. Minus 6, remaining electron is 4. And oxygen number 2 need just 4 electron. Okay. So this is 0 equal to 0. It means this is a correct structure. Now, what the question asks? Question asks the total number of lone pair of electron. So it having one pair. Okay, this is 2 pair and this is 3. The total number of electron pair will be 1, 2, 3, 4, 5, and 6. So 6 lone pair of electrons are present in oxygen atom of ozone. If they are asking number of electrons, then 12 electrons. But in this question, they are asking lone pair of electrons. So lone pair of electron means that is 2 electron form one lone pair. Okay. So there is total 6 lone pair. One lone pair, two lone pair, three lone pair, four lone pair, five lone pair, and six lone pair. So in ozone, there are 6 lone pair. So the correct answer is 6. So I hope, is it clear to all? Yeah. Beta, if you have any doubt, you can ask me in the chat box, right? Okay. Now, the next question is, what question state? There's a statement type of question. A two statement is given below, and you have to identify the correct statement and the reason for such a statement. Okay. So what does the question says that? According to the question, statement one say, dipole moment is a vector quantity, and by convention, it is depicted by a small arrow with the tail on the negative center and head pointing towards the positive center. मतलब ये कह रहा है कि मान लो आपके पास HCl है, राइट? क्या है हमारे पास बेटा? HCl है. ओके. So we know that Cl is electronegative element, NH is electropositive element. So how can you derive arrow for this? Okay. So dipole moment is a vector quantity and its direction is always from. Its direction is always from where? That is by small arrow with the tail on the negative center, like that, and head pointing towards the positive center. So this is absolutely correct. And statement one is absolutely correct. That is dipole moment is a vector quantity. It means it to give direct, it depends upon the direction as well as magnitude. And it is denoted by the small arrow with the tail on the negative center and the head pointing on the positive center. Okay. Now, statement 2. The crossed arrow of the dipole moment implies the direction of the shift of the charges of the molecule. Okay. It means the crossed arrow of the dipole moment implies not the direction of the shift of the charges in the molecule, but it symbolize the direction of shift of electron density in the molecule. So there is no point related to the charges. Okay. It means statement 2 is absolutely incorrect, where the statement 1 is correct. Okay. So the which one is the correct option? That is option number D. That is statement 1 is correct, but statement 2 is incorrect. Because in statement 2, they said the direction of the shift of the charges in the molecule. This is not the correct. They symbolize the electron density in the molecules, not the charges. Okay. So the correct option is D. I hope is it clear? It's a very simple question based upon the dipole moment, whether the dipole moment is a vector quantity or a scalar quantity, and how to draw the direction of the dipole moment. Right? Next, move to the next question. Okay. In this question, what the question asks, the number of a given orbital which have a electron density along the axis. Okay. So axial orbital की बात हो रही है यहाँ पे. कि इसमें से कौन कौन से ऑर्बिटल्स ऐसे हैं जिनकी इलेक्ट्रॉन डेंसिटी कैसे है, अलोंग द एक्सिस है। तो चलो देखते हैं एक बार अलोंग द एक्सिस कौन कौन सा हो सकता है। Now, if I'm talking about the px orbital, right? तो px orbital along the axis है, okay? px हो गया, सिमिलर वे में बेटा py हो गया, pz हो गया, एंड dz स्क्वायर हो गया, एंड dx स्क्वायर एंड y स्क्वायर हो गया। These five orbitals, that is these five orbitals, that is px, py, pz, dz square and dx square y square. These dz, dxy, dyz and dzx, they lie on the plane. Okay. They lie between the xy plane or yz plane or xz plane. So this py, pz, dz square, dx square, y square are the axial orbital. I hope it's a very simple question and it is numerical based question. So you have just count the number of orbital which is around the axial orbital and just write that. So for example, in this question, the correct answer is 5, right? Okay. Now, next, move to the next question. That is according to MO theory. Again, MO theory comes into the picture. According to MO theory, the bond order of O2, CO and NO2 respectively. Okay. So, how can you calculate bond order? For calculating bond order, we know the formula is half number of bonding orbital minus number of anti-bonding orbital. But it involves your lots of time to draw the electronic configuration of every molecule, right? For this, I use one trick and I want to explain to you how to calculate bond order in a few seconds only. Okay. So by using this trick, you can easily calculate any bond order within a second. Okay. So what is the trick? So please try to learn this trick, how to calculate bond order. Okay. For this, we know that just write number of electron, or we say sum of electron, sum of electrons. Okay. If the sum of electron is 10, 11, 12, 13, 14, 15, 16, 17, and 18, right? And just write below bond orders. If the sum of electron is 10, then the bond order is 1. If 11, it is 1.5. If 12, 2. If 13, 2.5. If 14, 3. Right? If 15, it will be again 2.5, 2, 1.5, and 1. Right? Okay, so this trick you use to calculate bond order for MO theory, molecular orbital theory. You are easily calculate bond order of any molecule very easily. Let's see how it's work. If, for example, if I'm talking about O2 negative, O2 negative having how many electrons, beta? O2 negative. We all know that O2 having 8, 16 electrons, and minus 2 means plus 2. That is 18 electrons. For 18, what is the bond order corresponding to 18 electron, beta? That is 1. O2, it means O2 negative having 1 electrons, right? Now, CO. So we all know that CO. CO means what? Carbon plus oxygen. So carbon having how many electrons? That is 6. And oxygen having 8. 8 and 6, 14. So corresponding to 14, कितना electrons है? जल्दी बताओ. Corresponding to 14, we have a bond order of 3. That is 3. Next is NO plus. NO plus. NO having 7 electrons, oxygen having 8 electron, plus means subtract 1 electron. That is 8 and 15, 15 means 1 gap. कितना हुआ? 14. Yeah. 14 means 3. So the correct answer is 133. 133. Yes, option number A. Option number A is absolutely correct. So by using such trick, we can easily calculate the bond order of any molecule whose electrons lie between 10 to 18. And mostly in JE, questions are asked only for such molecule having electron 10 to 18. So by using this trick, you can easily calculate the bond order of any molecule, right? I hope, is it clear to everyone? Yeah. If you have any doubt, beta, you can ask. No doubt? Okay. So this is very, very important. Try to learn this trick and you can easily solve such question in a very few seconds. Now, Next, move to the next question. This is also very important question, and this type of questions are coming very normally. These are the very important questions, and always came in almost every year. Okay, so how can we solve such question? Okay. Now the question is match list and list two. That is list one molecules are given, that is IF7, ICL4, XEF6, XEF2, and in list two number of lone pairs of electron on the central atom. For this also you need to draw the structure. Without drawing the structure, you won't able to predict where what is the number of lone pair or what is the number of bond pair. So for calculating lone pair or for calculating bond pair, you need to draw the structure. If I'm talking about IF7 beta, IF7, just remember, iodine belong to which group? Remember this elements also, which group they belong. Iodine is a central atom, right? Because the central atom, whose atom is considered to be central? Which is singular, okay? Which is single. For example, IF7, there is only one I atom now, and there is a 7F atom. So I atom is considered to be central atom, okay? So if I'm talking about the valence electron of the central atom, so I having how many valence electron beta? It belong to the 17th group. So it having 7 valence electron. And this 7 valence electron and 7 fluorine atom is also there, right? 7 fluorine atom is also there, right? So is there any lone pair in iodine? No, because it having only 7 valence electron and all 7 valence electron make bond pair with the other 7 fluorine atom. So there is no lone pair. So no lone pair in IF7. Okay, zero lone pair. So this is for IF7, right? This is for IF7. Zero lone pair. Now, ICL4 negative. If I'm talking about ICL4 negative, it means what? Cl, 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 and Cl. Okay, so I having 7 electron, right? And ICL negative. ICL negative means what? 7 electron of valence electron of iodine plus 1 negative. That is total 8 number of electron. Out of 8, 4 electron are bonded to how many lone pair beta? 2 lone pairs. Okay, so ICL4 having 2 lone pairs. So this is for ICL4 negative. Now, XEF2. So we all know that XEF6. Okay, XEF6. So in case of XEF6, we know that Xe having how many valence electron beta? 8. Out of 8, 6 electron are bonded pair, so only one lone pair is present. So in XEF4, only one lone pair. This is for XEF6. Similar for XEF2, there is a 3 lone pair. So this is for XEF2. So you can easily match. Okay. Now you got the answer now. XEF2 having only 3 lone pair, IF7 having 0 lone pair. Then you can easily match this question. Okay. So what is the correct option, beta? That is option number 2. Option number 2 is the absolutely correct. So such type of question were asked in a previous exam, and this is very simple to solve such type of question, right? And you will easily get 4 marks for this question. Just try to remember the structure and the atomic, this is valency of the element. Because if you won't know the valency of the iodine, then you won't able to calculate the lone pair or bond pair. Okay. So first of all, you need to learn some basic things like how to remember the uh, valence electron and their valencies and all. Okay. So I hope is it clear to everyone? Right. Okay. Now, this question is totally based upon the hybridization. Okay. So this is also very important questions, and it came around, many times such type of questions are coming in the examination, whether it is a JEE exam or NEET exam, these type of questions coming regularly. Okay. So now match list one and list two. Again, this is the matching type of question. If in this we have need to find the hybridization. So for hybridization, what is the concept? What is the concept to find the hybridization, beta? Yes. For hybridization, we know steric number rule. Okay, steric rule. What is this steric rule? What is this steric rule, beta? Okay. According to this rule, hybridization is calculated. Okay, if you want to calculate the hybridization of the any molecule or any complex, just write number of sigma bond, right? Number of sigma bond plus lone pair of electrons. Lone pair of electrons. By using this, you can calculate the hybridization. But in this question, right? In this question, there is a we can't we are unable to find the exactly number of sigma bond and lone pair of electrons. So such type of questions we also study this type of question in our coordination chemistry. Okay, in VBT theory or CFT theory, we are easily find the hybridization of such complexes. So let's start with how can you find. Basically, this question is very much similar to the question were asked in the coordination chemistry chapter. This is VBT and CFT. So for such question, how can you find the hybridization beta? Okay, just remember one thing. If okay, if coordination number is 4, right? If coordination number is 4, it will be either sp3 or dsp2. If the coordination number is 6, it will be either sp3d2 or d2sp3, right? It will be either sp3d2 or d2sp3. Now, if I'm talking about in this CO and NH3, okay? So CO having which type of hybridization beta? CO. Yes. Okay. So we all know that CO is a strong ligand where NH3 is a weak field ligand. So if I'm talking about CO means a strong ligand. Strong ligand always form DSP2, where the weak ligand form sp3. And similar here, sp3d2 is formed by the weak ligand, where the strong ligand form d2sp3. Just to remember strong and weak ligand, we can easily solve such question. So it is basically these questions are basically from coordination chemistry, right? So there is nothing to do it with the chemical bonding and all. So this question is from coordination chemistry. So try to learn this question as well. Okay. If the ligand is weak, then hybridization is sp3. If the ligand is strong, then the hybridization dsp2. If the in case of coordination number 6, if the weak ligand sp3d2 and the strong ligand d2sp3. Right. So let's start. NiCO4. We know that cobalt is a strong ligand. So their structure is dsp2. So A is 2. This is for A. Right. Now, if talking about B, that is NH3, it is a weak ligand as compared to CO. So their structure is sp. So this is for B. Now NH3 and H2O. So H2 is a weak ligand. So this is for H2O. This is the D. This is D and this is C. So this is the correct explanation of this question, right? So we can do such type of question very easily. Yes, we can utilize this rule in the next questions, okay, where we can find hybridization by using a steric number rule, that is the number of sigma bonds and the lone pair of electron, right? Let me give one example also. If I'm talking about NH3 and someone asks what is the hybridization of NH3, तो कैसे लिखोगे बेटा? सबसे पहले that is NH3 and having two lone pair. So it having how many sigma bond? 3 sigma bond plus 1 lone pair. That is 4. 4 means what beta? That is sp3. So it having sp3 hybridization. So we can calculate hybridization by using steric number rule as well, right? Okay. Now, next move to the next question. And this question is very important. And what is the concept behind this question? What is the concept behind this question, beta? The concept is valence shell electron pair repulsion theory. That is Vesper theory. So this question is totally based upon the Vesper theory. Okay. So how can you predict the shape? Okay. Just remember one thing. Either it will be AB4 type, AB5 type, or we say it may be AB3 type also. Okay. So AB4 or one more is AB6. So what is this AB3, AB4, AB5, AB6? So these are the type of molecule we have. And by knowing the number of unpaired electron and lone pair, we can predict the shape of this molecule and how the lone pair affect the shape of the molecule. This is explained by the Vesper theory. Okay, whenever the lone pair comes into picture, we use whisper theory for their shape, right? Now, if I am talking about XeF4, right? XeF4. We all know that in Xe we have how many valence electron in Xe? 8 valence electron, right? Xe having 8 valence electron. Okay? Now, out of this 8 electron, 4 electrons are engaged in making bond formation. So how many unpaired electron Xe having? Xe having 2 lone pair, right? 2 lone pair. So it having 4 bond pair, that is AB4, and 2 lone pair. So it lie in the category of AB6. It lie in the category of AB6. Yeah, 2 lone pair and 4 bond pair. Now, if I'm talking about SF4, if I'm talking about SF4, right? If I'm talking about SF4, right? In sulfur having 6 electron, right? So out of the 6 electron, 4 bond pair and 2 and 1 lone pair. So it having AB4L1. Okay, so it will be from AB5, right? Okay. Similarly, if I'm talking about NH4 plus, NH4 plus, right? NH4 plus having NH4 plus, yes, it having AB AB4, right? AB4, and there is no lone pair such in this question. Now, BRF3. BRF3 having BRF3. We all know bromine having 7 electron, 3 bond pair, and 2 lone pair. It means AB3L2. It also AB5, right? So how many of these are from AB5? That is BRF3, that is AB5, and SF4 AB5, and XeF4 is AB6. Now, when we know that the molecule lie in the category of AB5, AB4 or AB6, we can draw the shape. We can draw the shape of the particular molecule. How we can draw better? Let's see. Let's see this. Okay. Yeah. If I'm talking about AB6, okay, AB6 Xe, yeah, having F, and it having 2 lone pair now, just a 1 lone pair here and 1 lone pair here. What is the shape? Can you guess? What is the shape of XeF4? Yes, it comes to be square planar. Okay, so it comes to be a square planar. So this is for XeF4, right? Similar, if I'm talking about SF4, SF4. So for AB5, we have a shape like this. Okay, for this is a standard shape for AB5. Now, if 2 lone pairs, then put this 2 lone pair here. If only 1 lone pair is present, then put this lone pair here. So in SF6, only 1 lone pair are there now. So put this lone pair here. So what is the shape comes out to be? SF. This is S, 1F, 2F, 3F, 4F. So shape is seesaw. So shape is seesaw. So this is for SF4, right? Now, BRF3. BRF3 having 2 lone pair. Just draw like this. 2 lone pair. 1 lone pair is here. 1 lone pair is here. And this is BRF3. 1F, 1F, 1F. And this is BR. What is the shape? That is the T shape. So BRF3 having T shape. And in NH4, there is no lone pair now. The shape is tetrahedral. So by knowing the number of lone pair, bond pair, we can easily predict the shape of the molecule. Okay, by using Vesper theory. So just remember, in AB5, we have a 3 case, right? If 1 lone pair, put this lone pair here and the shape becomes seesaw. If the 2 lone pair, put this lone pair here and the shape becomes T shape. If the 3 lone pair are present, then these 3 lone present at the equatorial position. One is here, one is here, one is here, and the shape become linear, right? So only 3 cases are possible in AB5. If I'm talking about AB6, there are two cases which is possible in ABC. If there is no lone pair, then the shape is a square bipyramidal. If one lone pair is present, then put this lone pair here and the shape is a square pyramidal. And if the two lone pair are present like this in XZF4, there is a XZF4, then the shape becomes square planar. Okay. In AB4 also there is a three case. When no lone pair is present, then the shape is tetrahedral. If one lone pair is present, then the shape become this is the shape of NS3, right? And this is triangular, okay, pyramidal shape. If two lone pair present, then the shape become that is in the case of water H2O, the shape become vent shape or we say V shape, right? Okay, got it. So by knowing this, you can easily predict the shape of the molecule, right? Now, but if you have any doubt, you can ask. Any doubt related to this? No. Okay? Okay. Let's move to the next question. Among the following, the number of species having the linear shape. Okay? So in this question, they are asking among the following, the number of species having the linear shape. Okay? So this question is also from, we can say that this question is also belong from which topic? That is Vesper theory. Okay. So by knowing this, you can easily predict whether it is a linear shape or no. What do you mean by the linear shape? I'm talking about XZF2 beta. XZF2. XZF2 having linear shape or not? Yeah. XZ, F, F, XZ having 8 electron, 2 bond pair. It means 3 lone pairs are present. And we know that this lie in the case of AB2 L, AB2L3, right? AB2L3. And we know that for AB5, what we draw like 1 lone pair, 2 lone pair, and 3 lone pair. The shape become XZ, F, and F. The shape is linear, right? The shape is linear, right? Okay. So for such type, we can say that the shape become linear, right? Okay. Now, next is, if I'm talking about XZF2 is clear. Okay. Now, next is I3. I3 plus. So I3 plus having which type of shape? I3 plus. And one another is I3 negative. So out of I3 plus and I3 negative, I3 negative having linear shape. How can you say that? Okay. In I3, total how many electrons are present, beta? Yes, I3. If I'm talking about I3 like this. Okay. So in I3, it having I having how many electrons? That is 7 electrons. Out of this 7 electrons, how many and plus 1 negative, that is plus 1, that is 7 plus 1, 8. Out of this 8 electrons, 2 electrons are in bonding. How many unpaired electrons it having? It having 3 lone pairs. Okay. So 3 lone pairs and 2 bond pair. Again, this like AB2 and L3. Again, this is linear. I3 negative is also linear. We all know CO2 is linear. We all know CO2 is also linear. So CO2 is also linear. Now, XZF2 is linear. First of all, I3 negative is linear. CO2 is linear. Next is C3O2. So how can you draw the structure of C3O2 beta? C3O2. The structure is like C double bond O, and this comes out to be one another C double bond O. So this is the structure of C3O2. Though this is also linear in nature. CO2 is also linear in nature. So how many of these are linear? Okay, XZF2, C3O2, IT negative, CO2, and this is BeCl, not BeCl. BeCl is not linear, right? BeCl2 is linear, right? So this is BeCl2, not BeCl. So this is also linear. This is one. So how many of this? 1, 2, 3, 4, 5. So number of species having linear shape is 5. So just drawing the structure, we predict how many of the following electrons are linear in shape, right? Okay. Now, let's move to the next question. That is the bonding in which the following diatomic molecule becomes stronger on the basis of MO theory by the removal of electron. Okay, by the removal of electron. So you have to find which one is the more stable, right? Which one of the following is the more stable out of the following. So let's say if I'm talking about NO, right? If I'm talking about NO, how can you say that, beta? We know that one important concept here now. What concept you need to learn here? One important concept, bond strength, right? Bond strength is directly proportional to bond order. It means those molecule having or those diatomic molecule having more bond order or a greater bond order having more bond strength, right? So we just learned the trick to find the bond order. How can you find bond order of the following molecules, diatomic molecules, or any molecules? So what is the bond order of NO, beta? Just fast. NO means NO means 7 plus 8. 8, 7 is equal to 15. Corresponding to 14, we have a 3 bond order. 15, we have a 2.5 bond order. So it having 2.5 bond order, right? If I'm talking about N2, N2 means 14. 14 correspond to bond order of what? That is 3. Okay. Next is O2. So for O2, 16. What is the bond order? That is 2. For C2, it will be 12. For 12, for 10, it will be 1. For 11, it will be 1.5. For 12, it is 2. So this is for 2. Now for B2, that is boron. Boron. So boron having 5. So how will calculate 10? So this is for 1. So which out of this 5, which having the more bond order, right? N2 having the more bond order, right? N2. So N2 having more bond order. What does it mean? It means it having a highest bond strength. Okay? So out of the following, which one having the highest bond strength, beta? Yes, N2. But observe this question very carefully what they ask. Bonding in which the following diatomic molecule becomes stronger on the basis of MO theory by removal of electron. When you remove one electron, right? So when you remove one electron, right? If you remove one electron from NO, it become 14. 14. 14 correspond to what? That is 3. Got it? So by removal of electron from the anti-bonding molecular orbital, increase the stability. We know that the stability, as the number of electron in the bonding orbital increase, stability increase. And if the number of electron in the anti-bonding orbital increase, stability decrease. So removal of electron from the anti-bonding molecular orbital increase bond order. Now NO and O2 have a valence electron in pi star orbital, right? So if I'm talking about O2, so we all know that in O2, one electron, that is pi 2px star 1 and pi 2py star 1. So by removing this electron, number of electron in antibonding decrease, hence stability increase. So for such, out of these 5 options, which one is the correct? By removal of an electron, which diatomic molecule is more stable? That is O2. Because in O2, their electrons are present in a anti-molecular orbital. Okay. And if you remove electron from anti-bonding molecular orbital, then stability increases. Okay. So O2 become more stable. Right. Okay. If you remove 2 electron of O2, it becomes 3. The bond order becomes 3 for O2. Right. Okay. Next, move to the next question. Among the following, that is BF2, BF3H2, NH3CCl4 and HCl, the number of molecule with the non-zero net dipole moment. Which of the following having a non-zero or net dipole moment is not zero? Okay. So we know that the molecule having a linear shape, okay, the molecule having a linear shape having zero dipole moment. So try to find out the molecule which is linear in shape. If I'm talking about BEF2, BEF2 is linear, hence their dipole moment is zero. Now BF3, BF3 is not linear, but their shape is planar, and it's also shows zero dipole moment because they are fluorine, they cancel out, they effective cancel out each other, and the net dipole moment become zero. H2 having dipole moment. Okay. Now NH3 is also having dipole moment. CCl4, no. CCl4 having also symmetricity now. All CCl4 they are cancel out each other, right? So it having zero dipole moment. Now HCl having also dipole moment. So how many of the following with the non-zero dipole moment? That is HCl, NH3, and H2. That is 3. Okay. So the answer is 3. Right? Okay. Next, move to the next question. What the question asks, beta? The oxide which contain an odd electron at the nitrogen atom. So you have to find the oxide which contains an odd electron at the nitrogen atom. So how can you calculate, beta? Odd electron at the nitrogen atom. Okay. So for this, we need to see number of electron. If I'm talking about N2, right? If I'm talking about, here the question number 5. If I'm talking about N2, so N2 having how many electrons, beta? N2 having 14, 14, and oxygen having 8. So 14 and 8, 14, 6, 20, 22 electrons. 22 electrons. NO2 having, NO2 having N having, yes, N having 7 and plus 16. That is 16 and 4, 20, 23. Now, N2O3. N2O3. N2 means 14 and O3 means 24. 24, 34, 34, 38 electrons. Right? N2O5. If I'm N2O5, then it is a 40 and 16 into 5. 80. 80 plus 80, 90, 94. 94. So out of this, which having an odd number of electron, beta, that is 23, it means NO2. So NO2 containing odd number of electron, right? Okay. So this is very important question and a very simple question also. That is NO2 having 20 electron, or we say odd electron. How to draw the structure of NO2, beta? NO2, yeah, like this. And double bond O, and this is O having one electron only, not lone pair, one electron only. So this is the structure of NO2. So NO2 having only odd number of electron in all of 4 options. NO2 only the having. Now, next move to the next question. That is question number 6. They are asking among SF4, XeF4, CF4, H2 the number of species with the 2 lone pairs of electron. So you observe that many questions were coming on the whisper theory just to find the number of lone pair, shape, and the number of bonding. They are the very, very important questions, and it's also a very easy question. Once you understood the concept behind this, you can easily solve such type of questions, right? Now, what the ask in the question among the SF4, XeF4, CF4, H2, the number of species with the 2 lone pair of electron. We have to calculate the species having the 2 lone pair of electron. If I am talking about SF4 beta, SF having 6 electron. Out of this 6 electron, 4 are in bonding. So for bonding electrons, so only one lone pair. So it having AB4 L1 type. So it having only one lone pair, right? So this is not the correct one. Now XeF4. Xe having 8 electron. Out of 4 electron bonding, so it having 2. And it means this is AB4 L2. So it having lone pair of electron, 2 lone pair of electron. If I'm talking about CF4, right? If I'm talking about CF4. So if CF4 also 4, 4, 4. So there is no one pair electron. Now H2O. So H2O having O, H, H. So it having two lone pairs. So only H2O and XeF4 having two lone pairs. Okay. So the correct answer is 2. So this is also a numerical integer value type question. So just write the answers. So out of this 4, only XeF4 and H2O having two lone pairs of electrons. Right? Okay. I hope is it clear to everyone? Okay. Now, the next question is you have to identify the incorrect statement for the PCL5. Okay. For the PCL5, you have to identify the incorrect statement. Okay. The first is what is the structure of PCL5? Okay. So let me first draw the structure of PCL5. So this is PCL5 structure. Okay. What the structure called? It's known as trigonal bipyramidal. That is TBP. That is trigonal bipyramidal. Right. So this is a trigonal bipyramidal structure. These are called equatorial bond. Right. These are called equatorial bond having 120-degree angle, and these are called axial bond. These are called axial bond. Right. And having 90-degree angle. Now, read first point. In this molecule, orbital of the phosphorus are assumed to be undergo sp3 dehybridization. This is absolutely correct. PCl5 having trigonal bipyramidal having sp3 dehybridization. This is correct. The geometry of PCl5 is trigonal bipyramidal. This is also correct. We also always already draw this. PCl5 has a two axial bond stronger than the three equatorial bond. This is wrong because we know that axial bond are weaker bond. PCl5 on heating easily dissociate into PCl3 plus Cl2. These two axial bond are very weaker because there is large repulsion among the axial bond. So this bond is weaker and they easily break. So if I'm talking about the equatorial and axial bond and comparison, the which bond is stronger, whether the axial or equatorial, then equatorial bond is stronger, not the axial. So this is the wrong statement. Next is the three equatorial bond of PCl5 lie in the plane. Yeah, three equatorial, जिसको हम लोग बोलते हैं equatorial bond, they are lying in the plane. All the statement except C is correct. So our correct answer is option C because in this question they asked to identify the incorrect statement for the PCl5 from the following. So the correct answer is option number C. Right? Now, the correct order of increasing intramolecular hydrogen bonding strength. Okay, you have to find the correct order of increasing. So this question is basically based on what? Hydrogen bonding. Hydrogen bonding. So what is the concept behind this question, beta? We know that now hydrogen form bond only with the three elements. Just remember that is phone. Try to remember this with phone. Okay, phone means fluorine, oxygen, nitrogen, because only these three elements having electron activity greater than hydrogen. So hydrogen form a bond only with these three element known as hydrogen bonding. So in this question they are asking increasing intermolecular hydrogen bonding strength. So which one is the more stronger hydrogen bond, Sc and H2O or NH3, right? So if I'm talking about CH4, right, SCN and NH3, right? So in NH3, hydrogen bonding is there, right? In NH3, hydrogen bonding is there. So this bond is obvious. It is more stronger than other two. That is CH4 and SCN. So there is no exception in this, and we can understood this very easily. Now, what about CH4 and SCN? Out of this, which one having stronger hydrogen bonding? So in CH4 and in SCN, there is a more electronegativity difference, right? This is SCN, this is partially negative, and this is partially positive. So it having more electronegativity difference, so it will be more. In CH4, carbon hydrogen almost having a similar electronegativity. There is much more difference in their electronegativity. That's why the order become this. NH3 because due to the hydrogen bonding, because hydrogen form bond only with these three FON, and SCN and CH4. So this is our correct explanation. So what is the correct option here, beta? That is CH4, SCN, and NH3. That is option number C. Option C is absolutely correct, right? Okay. Now, the hybridization of P exhibited in PF5 is x dy. We know that in PF5, what is the hybridization? PCl5, PF5. Hybridization is sp3d1. We already saw such type of question, right? So here sp3d1. What is x? What is the value of y? The value of y is 1. If they ask what is the value of x, then the value is 3. So we can easily solve such type of questions in a very easy way, right? Okay. Next, do last question, and this is also very, very important question. What is the concept behind this question? So this question is basically from the covalent character. And how can you predict the covalent character? By using Fazan rule. What is the Fazan say? What is the Fazan state that? Fazan rule state that for the molecule or for the element to be covalent, it must possess. What is the two condition? That is, cation side should be small. Cation side, sorry, cation size should be small, and anion side should be large. And charges on both cation and anion should be high. So this is the most important condition for the molecule to be covalent. Now, if I'm talking about LiCl, NaCl, KCl, CdCl, in all of these four, Cl is common. Now, if I'm talking about lithium, sodium, potassium, and cesium, out of these, which cation is smaller? So lithium is smaller, and LiCl is more covalent, and CCl is the least covalent, right? So the correct option is LiCl. That is option number A and D. That is AD. Out of NaCl and KCl, so that is A, after this B. So A, B, C, D. So this is the correct. That is option number C, right? So we can learn, we can do such kind of question by just remembering the Fazan rule. So in today class, we will discuss about the valence bond, Vesper theory, right? Vesper theory, dot structure, how to calculate lone pair, bond pair, and MOT theory, how to write the electronic configuration, how to calculate whether it is a paramagnetic or a diamagnetic, whether it having unpaired electron or not, how to calculate spin magnetic moment. So these type of question are mainly came in these chapters. We observed previous year PYQ's questions. So mostly questions are asked from this topic. So try to solve such questions. Okay. Try to solve such questions. And it is, I once again, I repeat, it is very, very important chapter and it is very easy chapter. So just remembering some tips and tricks, you can easily solve such type of question. Right. So प्रिपेयर वेल, इसको अच्छे से करो पूरा. एंड नेक्स्ट क्लास में फिर मिलते हैं हम लोग, वहां पे फिर हम लोग डिस्कस करेंगे अपना हाइड्रोकार्बन है अपना नेक्स्ट क्लास, तो उसको हम लोग डिस्कस करने वाले हैं. तो टिल टेक केयर, और इसको तुम लोग अच्छे से सॉल्व करना. ओके ओके, तो मिलते हैं नेक्स्ट क्लास में. टिल टेक केयर, बाय.